Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. Now, we are starting with some questions of complex numbers. Complex numbers is part of P3, paper 3. The three major subtopics of complex number are algebra, modulus argument, also known as polar form or the trig form, and the third one is loci. Now, let me first pinpoint to you from where I am picking up these questions. So they are from your topical past papers. This is topic number 9, that is complex numbers. This one is for algebra. Lot of questions over here. And let me move ahead. And then we get started with the second thing, which is somewhere over here. This is the third thing, that is loci. And the questions are mixed up. And yes, there is a section in the middle, which is somewhere over here. Okay, so I think it starts from here. And that is the section on trigonometry. So I'm picking up different questions from these three sections. So going back to this, let's look at the first question. The first question is about this thing. Let me read it. Now, this is a combination of algebra and it's a combination of trigonometry. It's more of algebra. So now the question says the variable complex number, and let me underline it. The variable complex number z is given by such and such. We solved a similar question in class, I think a day before. Z is in terms of theta. There is a cos over here. There is a sine over here. Where theta takes all the values in this particular interval. The first part, show that z minus I, the whole thing modulus equals to 2 for all values of theta. Hence, sketch in an Argand diagram the locus of the points representing D. And then the second one, prove that the real part of 1 over this thing is constant for this. So that question was very, very similar. And that is actually involving double angle. This one is not involving double angle. Now, in this first question, if I focus on the very first part, so Z is this thing. And let me write, first of all, when such a question comes, use some symbols. Sine theta is denoted by S. Cosine theta is denoted by C. So I can write Z as 2C plus I bracket 1 minus 2S. That makes life very, very simple. Now I'm interested in Z minus I. So Z minus I, that would be 2C plus I minus 2SI. And then I am subtracting an I over here. So this I over here, this thing is subtracted. So when this thing is subtracted, what happens? I'm left with the 2C. I'm left with the 2SI. The I and the I cancel out. So this is 2C minus 2SI. This is Z minus I. Now, if I'm interested in Z minus I, the whole thing modulus, that is 2C minus 2SI, the whole thing modulus. Now, keep in mind, this is the real part. Keep in mind, this is the imaginary part along with the negative. Remember, when Z is X plus IY, the real part of Z is X. The imaginary part of Z is Y. Therefore, magnitude of Z, that is the real square, that is the imaginary square, the whole thing square root. So therefore, over here, when I'm taking the modulus of this thing, that is 2C, the whole thing square, and this is negative 2S, the whole thing square, square root. That is 2C square, that is 4C square. And this is 4S square, the whole thing under root. That is 4 common, C square plus S square, the whole thing under root. We know that C square plus S square is 1. So this is square root of 4. So square root of 4 comes out to be 2, and that is what they are asking us. So therefore, Z minus I modulus is equals to this thing. Now it says, hence sketch on an Argand diagram. So now what should I sketch? What exactly are we sketching? We are sketching Z minus I modulus equals to 2. We know it's a circle. And let me readjust it a bit. So Z minus 0 plus I, the whole thing modulus equals to 2. It's a circle, definitely. The center of the circle is 0, 1, and the radius of the circle is 2 units. So all you have to do is to draw a grid. So let me just pick a nice grid over here. And over here, I have drawn a grid like this. And let me draw a circle over here. So I'm drawing a circle, but the radius is 0, 1. So first of all, let me mark the radius. So the radius is this thing. And the the center is 0, I. This is I over here. So this is I over here, and the radius is 2. So let me just draw a circle a little bit bigger, something like this. Okay, so that's how this thing is drawn. That is this part. So all good, all clear. So now what you can do is that on the WhatsApp, you can acknowledge if you want to. So let me write this thing. This is question 24. This is part 1. And it's all good, all clear. So I'll simply write the question part, and then what you can do is that you can acknowledge it. Okay, instead of doing it individually, I think just a show of hand on the message itself, that would do the job. So now the first part is all done, all good. Now let's focus on the second part. Now it says proof that the real part of this complex number, this thing in the denominator, 1 is in the numerator, is constant for all values of theta. Now over here, let's start working. First of all, we know that z is what? That is 2c plus I minus 2si. And now I want to add a 2 and then subtract an I. So this is 2c plus I minus 2si, put it inside a bracket. And this is z over here. This is z over here. This is z over here. And then what do we subtract? We can add plus 2 and minus I. So plus 2 and minus I. So now what cancels off? So we cancel off the I and the I. And this 2 still remains. 2 is a real part. 2c is a real part. So this is 2c plus 2. And this is minus 2si. That is this thing. And what if I take 2 common? So this is c plus 2. And this is a big bracket over here. Minus si. That is what is left over here. So this is just the denominator. I'm focusing on the denominator. Now 1 over z plus 2 minus I is the same thing as 1 over, I'm writing this 2 at the top, this 2. And this is c plus 2. Actually, this will become 1. So let me correct myself. So because I've taken 2 common out, c plus 1 minus si. Now what do I need to do? I need to rationalize. So this is c plus 1 plus si. This is c plus 1 plus si. All good, all clear. So now when you are rationalizing this, what is happening? So now you would say that, let me write it at this corner, a plus bi into a minus bi, that is equals to a squared plus b squared. And let me just check one thing. And that is the recording thing. I'm very, very particular. Yes, the recording is on. Perfect. So now when I do this, let's focus on the denominator. So therefore, the denominator is c plus 1 whole square plus s square. And we would simplify it a little bit later. This half written in black color remains as it is. This is c plus 1 minus si. And now what I can do is that, let me simplify this. So therefore, the denominator is c square plus 2c plus 1 plus s square. And I can then use c square plus s square is 1. 1 plus 1 is 2. So this is 2c plus 2. Let me just write it at this corner. This becomes 2c plus 2, which can be written as 2 bracket c plus 1. So therefore, we have 2 bracket C plus 1. And we have at the top this thing. This is half bracket C plus 1 minus half SI. This is half bracket C plus 1 minus half SI. And they are saying that the real part is a constant. So just focus on the real part. So let me shade the real part in orange color. That is this thing. And just focus on the denominator. So when we focus, the C plus 1 cancels out. So the real part is half divided by 2, which comes out to be 1/4. Therefore, the real part is 1/4. So now I have also completed the second part of this question. I hope it's all good, all clear. So now the first question is done, and it was about algebra. And the next thing, that was trigonometry, a little bit of trigonometry and more of algebra. Now, if I look at question number 21, so 21 has 2 parts. The first part is algebra. And the second part, that is about loci and the drawing and the greatest least values. So let me also label this, the green one, the red one. So let's focus on the red one first. It says the complex number W and U and W satisfying these 2 equations are there. Solve the equation giving all answers in the form such and such where X and Y are real. So now, first of all, what I'll do is that I'll write U minus W is 4I. That is equation number 1. And this is UW equals to 5. That is equation number 2. I think it's your choice. I think I'll make W the subject. That is 5 over U. And I'll plug it in over here. So therefore, U minus 5 over U equals to 4I. And then we have U square minus 5 is equals to 4UI. All good, all clear? So now what we can do is that we can write U square minus 4UI minus 5 equals to 0. Seems familiar? We have solved some questions which were quadratic and one of the coefficients were unreal. So this is what you are getting for right now. So now underneath it, write like ax square plus bx plus c equals to 0. And a is 1. It's written in terms of u. So a is 1. B is negative 4i. C is negative 5. Let me evaluate b square minus 4ac first. That is negative 4i whole square minus 4 into 1 into negative 5. This comes out to be positive 20. This comes out to be 16i square. But remember, I square is negative 1. So this is negative 16 plus 20, which is negative 4. So far, so good. So now this is question number 21 that we are solving, the first part. Now, what we can do is that write down the formula. U is equals to minus b plus minus square root b square minus 4ac. The whole thing over 2a. So this is minus 4i plus minus b squared minus 4ac square root of negative 4. So I love to do it separately so that I'm a minimalist. I believe in less clutter. So I want things to be separated. Divided by 2a, that's 2 into 1. This is 4i plus minus square root of negative 4 is plus minus 2i. So this is plus minus 2i divided by 2. Now over here, it's a good idea that we should recap this thing. Over here, I think 20 minus 16, this is positive 4. My bad. So I just pinpointed a mistake. So this is positive 4, and this is simply plus minus 2. So therefore, this is a positive 4. Let me just write it this, and let me just remove this. Okay, so now I think it's all good, all clear. This is 2i plus minus 1. So therefore, the two answers are US. Let me write it in the real form. This is 1 plus 2i, and this is US minus 1 plus 2i. It's not the normal conjugate, because the normal conjugate that we know of, that is a plus bi, a minus bi. Whenever we obtain roots, that is of this form. But provided, what is provided? What is definite? Provided the coefficients are real. But if the coefficients are not real, that is the case over here. If one of the coefficients are complex or imaginary, then you get a different type of conjugate. And we have seen such questions in class. So this is like imaginary plus real, imaginary minus real. But we are not interested in that. We are just solving this for the sake of solving it. So U is this. What about W? So W is 5 over U. So let me add a page over here. So therefore, W is 5 over U. So this is W is 5 divided by 1 plus 2i. W is 5 over minus 1 plus 2i. And now you should rationalize. This is 1 minus 2i, 1 minus 2i, multiply and divide with minus 1 minus 2i, minus 1 minus 2i. And let's multiply it out. This is 5 bracket 1 minus 2i in the denominator. This is 1 square plus 2 square. So this is 5. This is 1 minus 2i. This is 5. This is 1 minus 2i. And over here, W equals to 5 minus common, minus 1 common, 1 plus 2i, divided by negative 1 square plus 2 square. So this is 5, negative 1, 1 plus 2i divided by 5. This is negative 1, negative 2i. Therefore, the final answer, what are we interested in? We are interested in giving all answers in this form. So U is 1 plus 2i, first of all. U is 1 plus 2i. And then the corresponding value of W is 1 minus 2i. And then the other value of U is minus 1 plus 2i. And the corresponding value of W is minus 1 minus 2i. That is the answer for this part. So technically, it is kind of a simultaneous equation that we have solved. So this is like simultaneous equation related with complex numbers. So that is the first part. So now let me write over here. That is 21. And this is part 1. So that is all good, all clear. 21 part 1, A2 math 1, A2 math 2. Okay. So now let's read the second part. Why don't you read it first? Okay, so now I'll get started with this. The question says, on a sketch of an Argand diagram, shade the region whose points represent complex numbers satisfying the inequalities. So what are the inequalities that we are talking about? We are talking about 3 different inequalities. Let me highlight them. The first one is the red thing. The second one is the blue one. And the third one is this one. And we did this part in class, but we did not reach the second part. The main thing is the second part. So now, first of all, when we talk about the red part, what are we talking about? I'll just emphasize on that, the second part, and then the third part. Now, the first part is about this thing is a circle. The second one is a half line. So recognition is half the job done. The third one, that is again a line. So first of all, z is x plus iy. Real part of z is x. Imaginary part of z is y. When it says real part of z is greater than or equal to 1, it means what? It means x is greater than or equal to 1. So that is the first thing. The half line argument, z minus 0 plus 0i equals to lesser than or equal to negative pi by 4. Therefore, this half line has a starting point, that is the origin. And the angle is pi by 4. And we are interested in lesser than negative pi by 4. We will draw all of them. But first, make notes for yourself. Circle, do the adjustment. Z minus negative 2 becomes positive 2. Positive 2i becomes negative 2i. Close the modulus, lesser than or equal to 2. It's a circle. The center of the circle is 2, negative 2i. And the radius is 2 units. And again, its points are region inside circle and including the circumference. So that means it's a solid circle. The same goes over here. Points are inclusive. Over here, points are inclusive. What do I mean by that? When we say greater than or equal to, lesser than or equal to, that is a solid line. And when we simply say greater or lesser, that is a dotted line. So now let's draw this for 5 marks. And then for 1 mark, it's asking for the real part of z. It's unfair to ask only for 1 mark because this is the difficult part. So this difficult part is only worth 1 mark because the examiners don't want you to lose that many marks. So now let's get started. First of all, I need a grid. And let me draw a grid, not that thick. Okay. And let me draw something over here. And let me draw a circle. But before that, I need 2 minus 2. So first of all, this is imaginary. This is real. This is the origin. This is 1. This is 2. This is 3. This is 4. This is 5. This is negative I, negative 2i, negative 3i, and so on. So 2 minus 2, that is this thing. And circle is in red color. So 2 minus 2, that is the center of the circle. Let me use red color for this. And the next thing is that I need to draw with radius 2 units. So that means it would be touching the circumference because this is 2 units. Sorry, the circumference would be touching the real axis. The circumference would be touching the y-axis. So let me get started with this. So it's like this, and like this, and this point, and this point, and it goes like this. That's how a beautiful circle is created. So this circle is now created. Okay, so the first thing is done. Then we have a half line starting from the origin, making an angle of pi by 4. So let me use a blue line. And we are starting from the origin. And it's going like this. It's a little bit. Okay, I'll just pause for Azan. So I'm just pausing the recording. Now let's continue. So now I have drawn this blue line which is for this thing, the half line over here. It's making an angle of pi by 4. And the inequality is lesser than or equal to negative pi by 4. Now, negative pi by 4 is below the x-axis, below the real axis. This is clockwise. Since it's 45 degrees, it should be passing through the line or on the line y is equals to x or y is equals to negative x. Because when we go this way, this 90 degree is divided into two parts. So this is 2, this is minus 2, this is 3, this is minus 3, and so on. So that is why that is drawing the line without using a protractor. So now this thing is done. Now, if I focus on these two, it's inside the circle, but the angle is lesser than negative pi by 4. So this is negative 45, negative 50. If I talk about in degrees, negative 50, negative 60, negative 70, negative 80, and all these things are increasing. So basically, we are focusing on this region. But wait a minute. There is also a third one. Okay, so there is another azan. I'll just have to wait for this. Now we are starting again. So we were talking about, first of all, drawing a circle after the adjustment, and we want to shade it all the points inside the circle, including the circumference. There is a half line which is starting from the point 0, 0. It's making an angle of negative pi by 4. Since this is less than or equal to, therefore, it should be below this half line, but inside the circle. But wait a minute, there is a third thing also. And what is that third thing? That third thing is this thing, x is greater than or equal to 1. So now draw the line x is equals to 1. That's going like this. And greater than or equal to 1. That means inside the circle, below the blue line, and to the right of this line. So therefore, the shaded region, which I'll draw in purple, is this thing. So let me just shade this thing. This thing, this region over here like this. And this is the region. What is this forming? So now this thing over here, that is the shaded region. So all good, all clear. Just ignore the overlaps. So now once this is done, that is for 5 marks. Now this part, calculate the greatest possible value of real part of z. Greatest possible value of real part of z means greatest possible x value for points lying in the shaded region. Now, if I look at the diagram, I see the greatest value would be this far end over here, somewhere over here at this very end. So this x coordinate would be the greatest value. So now what I can do is that I just want to erase a little bit. Okay. So now I am interested. Let me use a reddish color. And I'm interested in this, finding this value over here. Now this is another color. Let me use it. So therefore, I'm interested in finding this value. So this x coordinate is what I'm looking for. From here all the way till here, that is what I'm interested in. Now, if I label this thing, let me choose a different color, a green color, a color that I've not used as such. So blue, red, green is used. I think purple is the only one that's left. So let me just draw this like this. So now this line is there. And then we are interested in this. And I'm interested in this also. So let me label it. First of all, this is O. Let me label this thing as A. And let me label this point as B. So this point is B. Let me label the center as C. So now O is the origin, that is 0, 0. C is 2, negative 2. Therefore, OC magnitude is 2 square under root, which comes out to be square root of 8. And we know that CB that is the radius, that is 2 units. In other words, OB, that is root 8 plus 2. This is O, this is C, this thing is root 8. CB is the radius. So OB, that is from origin till this thing, the greatest distance. This comes out to be 8 plus root 2. So therefore, let me write over here 8 plus root 2 over here. And this angle over here, that is 45 degrees. So your calculator could be in the degree mode, use 45 degree. Your calculator could be in the radian mode, use pi by 4 radians. This is a right angle triangle because this is like the y-axis and this is horizontal. I'm interested in this thing. I'm interested in AB. So therefore, sine of 45 degrees is equals to AB divided by 8 plus root 2. Sine of 45 is root 2 over 2 multiplying with 8 plus root 2, that is equals to AB. So either leave the answer in the exact form or leave the answer in decimals. They are least bit concerned. That is the greatest possible value of real part of Z. Just have a good look at it. So this is worth much more than 1 mark, at least 2 or 3 marks. But they have deliberately kept it 1 mark because they don't want most of the people to lose marks, because not everyone is so fortunate enough to be taught in the rightest possible way, in the clearest possible way. So just doing my part to explain things in great detail. So now this thing is done. Let's look at this question number 28. First, have a good look at it. Have a good look at question number 28, and then I'll proceed with question number 28. Okay. It says the complex number 2 plus 2i, let me just reduce the brightness a bit. The complex number 2 plus 2i is denoted by u. So this is denoted by u. Find the mod and argument of u. That is the first thing. The second thing, sketch an Argand diagram showing the points representing the complex number 1, I, and u. Shade the region whose points represent the complex number C, satisfying both the inequalities. Which two inequalities are they talking about? They are talking about the blue inequality. They are talking about the green inequality. And then it says, use your diagram, calculate the value of modulus of Z for the point in this region for which argument of Z is the least. So a beautiful question. Now, first of all, the first part has nothing to do with the rest. Let's think so. U is 2 plus 2i. Just a small grid would do the job. This is 2. This is 2i. This is imaginary. This is real. There is a dot over here. Just join this thing with origin. Basic angle, tangent of alpha is 2 over 2. Alpha is pi by 4. Argument of u is also pi by 4 because it's in the first quadrant, and modulus of u is 2 square, square root, and this comes out to be square root of 8. That is the first part. Now, what else are they interested in? They are interested in the real part is the 4 and the 3 mark part. So this 4 mark, this 3 mark, this 7 mark, that is what I'm interested in. Now it says sketch an Argand diagram showing the points representing complex number 1, I, and u. Now, first of all, let me draw the grid. So I'll just draw somewhere over here. Okay. So first of all, I'm interested in 1. 1 means 1 plus 0i. So 1, I, and u. So this is 1. Mark this point. This is I. Mark this point. And u is 2 plus 2i. So 2 plus 2i, that's right over here. All these 3 points are marked. Shade the region whose points represent complex number which satisfies both the inequality z minus 1 is lesser than z minus I. Z minus I, first of all, it's 1. Z minus 1 plus 0i is lesser than or equal to z minus I. So that is, hold for a second. I'm just thinking about the recording and all things is clear. Some people are messaging me. Just hold for a second. Z minus I, 1 is 1 plus 0i, z minus 0 plus I. Okay, let me just have a look because it kind of disturbs my whole thing. Okay, no, it's not. Okay, so now this thing is done. 1 plus 0i, 1 plus 0i, let me label this point as A. And 0 plus I, let me label this point. Let me use a different color. Let me label this thing as B. So this is B, this is A, and it's closer because of the lesser sign. It's closer to A as compared to B. It's closer to A as compared to B. So we know that it's a perpendicular bisector. And without any working, I can say the perpendicular bisector is y is equals to x. Because I know my math right, I know that a point such as 1, 0 becoming 0, 1, that is reflection in this line. So that is the knowledge of O-level math that I've used over here. You can just do the working. It's pretty basic. So if I draw a perpendicular bisector in blue color, so let me draw a perpendicular bisector like this. And it's going like this. And we will shade which region? We will shade the region that is closer to A. So we would shade this particular region, but hold for a second. The next thing, z minus u is less than or equal to 1. So they're just using u over here. Z minus 2 plus 2i, that is u, is less than or equal to 1. So draw a circle in green color in which the radius is 1 and center is 2 and 2. So I'm starting here, 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 and here. Okay, so this thing is done. So this thing is the green one. Let me just erase this. So this thing is this green color thing that I've drawn. And over here, this thing is the blue color thing that was already drawn. That's right over here. Okay, so let me also erase this thing, stroke eraser, and let me draw in pen. Okay, so this is better. All good, all clear? So now it's inside the circle, solid circle, below this line. So therefore, which is the shaded region? The shaded region is this orange region that I'm highlighting. Let me make it thinner. Okay, so that is the basic thing that needs to be highlighted. Okay, all good, all clear? Now, what are they saying? They are saying use your diagram, calculate the value of modulus of z for point in this region for which argument of z is the least. So let me draw argument of z. What is argument of z? Argument of z is a half line. And the starting point is origin, 0, 0. So there are many half lines that can be drawn. For example, if I draw this half line, so I can just rotate this around and maybe I can be drawing it like this. Let me draw different ones. Maybe a line like this, a line like this. There are many different half lines that can be drawn. But I'm interested in the one with respect to this shaded region. So therefore, the half line that will be drawn would be like this. All good, all clear? So over here, this argument of z will be the least because over here, that will be the greatest. If they were asking for the greatest, that would be this line. So this is least. And over here, this one is the greatest. But we are not interested in the greatest, so just remove that. We are interested in modulus of z. What is the value when the argument is the least? That means the distance from here till here. That is what we are interested in. This is O, this is A. A is already marked. So let me write, this is C and this is D. And this thing is the radius. So let me just take this thing out. So let me just draw this line. Let me choose blue color. So therefore, this would be like this. The purple color is right here. And then the green one like this. And then the blue one like this. Okay, now let me do the working. This is O, this is D, this is C, this is 90. The radius is 2 unit. And we know what is OC. OC is right over here. That is root 8. So that is why it's being used. And now we are interested in OD. Let's label this thing as M, or let's write this thing as OD. So root 8 whole square is equals to, the radius is 1 unit or 2 unit? 1 unit. The radius is 1 unit. That is equals to OD square plus 1 square. 8 is equals to OD square plus 1. OD square is 7. OD is root of 7 units. And that is the answer. So let me just shift this thing a little bit below so that we don't mix up the two. So this was a perpendicular bisector. This was a circle, center 2, negative 2, 2, and radius is 1 unit. So we did all the shading and everything, and that was the final step. The final step was realizing this thing, that when the argument z is the least, that is a half line starting from the origin, touching the shaded region. And if it was a full circle, the argument would be maximum over here. And for this region, the maximum argument is this, which is 45 degrees. If it was a full region, yes, then over here. But since we are talking about this shaded region, they're not asking about maximum because that's too obvious. They're asking about the value of modulus of z when argument of z is these. So read carefully. What exactly are they asking? So all good, all clear? I think I'll just stop over here. And that is the end of this lecture. So we did algebra, we did trig questions, we did loci question. Till the next class, take care.